Hello and welcome to Sciprex. In today's video, we'll explore on electro/mechanical technician. Firstly, a short recap on electromechanical technician. An electro/mechanical technician is a skilled professional who installs, maintains, troubleshoots, and repairs electrical and mechanical systems in various settings such as manufacturing plants, production facilities, or field operations. Their duties often include reading blueprints and schematics, testing equipment, and ensuring machines operate efficiently and safely. These technicians play a crucial role in minimizing downtime and supporting automation and production goals. Here are some formal, friendly question and answers for an interview preparation. Q1. Can you describe your experience with both electrical and mechanical systems? Answer. Certainly. I have hands-on experience installing and maintaining mechanical components such as motors, pumps, and conveyor systems, as well as electrical systems including wiring, circuit breakers, and PLCs. My work often involves troubleshooting and repairing integrated systems to minimize downtime and ensure smooth operations. Q2. How do you approach diagnosing a malfunctioning machine? Answer. I start by gathering information on the symptoms and checking the machine's history. Then, I visually inspect both electrical and mechanical components, use diagnostic tools like multimeters or thermal cameras, and follow schematics to isolate the issue. I aim to identify root causes to prevent recurrence. Q3. How would you approach troubleshooting an intermittent fault in a machine that's affecting production but doesn't show any error codes? Answer. Intermittent faults can be tricky, so I approach them methodically. First, I gather information from operators on the fault's timing and symptoms. Then, I review system logs and wiring diagrams to narrow down the possible causes. I would use tools like vibration analyzers or thermal imagers to detect mechanical inconsistencies and use a multimeter or oscilloscope to monitor electrical signals over time. If needed, I'll simulate load conditions to reproduce the issue. Documentation is key for tracking patterns and solutions. Q4. Explain how you would diagnose and repair a servo motor that is not responding correctly within a robotic assembly system. Answer. I would start by checking the servo motor's power supply and control signals to ensure it's receiving correct input. Then I'd verify encoder feedback using a diagnostic tool to confirm accurate position data. If the wiring and connections check out, I'd test the driver or amplifier for faults. I'd also inspect mechanical load components like couplings or gears to rule out binding. If necessary, I'd swap the motor with a known working unit to isolate the issue. Calibration and alignment would be final steps after repair. Q5. What safety practices do you follow when working with high voltage equipment or moving machinery? Answer. Safety is a top priority. I always follow lockout-tagout procedures where appropriate PPE and ensure equipment is powered down before beginning work. I also stay up to date with OSHA and company-specific safety standards. Q6. Tell us about a time when you successfully resolved a complex technical issue. Answer. At my previous job, a production line frequently stopped due to a sensor fault. I traced the issue to a wiring short inside a junction box, which wasn't obvious at first. I replaced the faulty wiring and rerouted it to reduce wear. This significantly reduced downtime and improved reliability. Q7. Describe how you would integrate a new sensor into an existing PLC controlled system. Answer. I would begin by reviewing the sensor's specifications: voltage, signal type, analog, digital, and output range. I then modify the PLC's input module wiring to accommodate the new sensor and update the ladder, logic or function block programming to process its signal correctly. Calibration of the input scale and testing with live values would follow. I document changes for future maintenance and ensure the sensor's addition doesn't conflict with existing I/O or program scan times. Q8. A machine is overheating regularly despite all cooling systems functioning. What would be your investigative approach? Answer: overheating could stem from electrical, mechanical, or environmental factors. I'd inspect for excessive load, motor misalignment, or bearing wear increasing friction. I'd check voltage and current to look for imbalance or overcurrent. Cooling fans and airflow paths would be examined for dust or obstructions. Ambient temperature and ventilation might also be contributors. Thermal imaging would help locate heat concentration. Ultimately, I'd aim to identify root cause, not just treat symptoms. Q9. How comfortable are you reading blueprints and technical diagrams? Answer: I'm very comfortable with both. I regularly interpret electrical schematics, mechanical drawings, and manufacturer manuals to guide installations and repairs. Clear understanding of diagrams is essential in diagnosing problems quickly and accurately. And Q10. How do you ensure system reliability in a high-throughput automated environment? Answer: preventive and predictive maintenance are key. I use data from sensors and control systems to monitor trends like vibration, temperature, and runtime hours. I schedule regular inspections, firmware updates, and calibration of key components. I also ensure critical spares are available and maintain accurate maintenance logs. Collaboration with production and engineering teams helps proactively resolve emerging issues and plan system improvements for better reliability. If you like this video, give it a thumbs up, subscribe to Sciprex, and hit the bell icon so you will never miss an update. Thank you for watching Sciprex. Keep learning and stay inspired.